why it is important this day, why it is fundamental, why it is an exceptional opportunity these days to study computer science. And what are the real and actual opportunities that, and the real projects and the world challenges that we can face. And the people that are going to study and get a degree in computer science these days will have to face an enormous amount of interesting challenge, of world-changing challenges. Okay, this so many things have been said about myself, and you can easily find information if you Google my name, because there are not many people actually with this same name. And I will be ready to answer questions offline about any of the research projects or research interest or any of the activity I've been involved or I'm involved to. So if you want to, if you are interested in any other things that is not just CBSE, you can certainly write me an email or contact me on LinkedIn. My name is Manuel Mazzara, and my name Manuel, it's an Hebrew name, and it means God with us, while Mazzara is the name of a relatively small Sicilian town, which has a Phoenician origin, and it means citadel. It was actually a fortress. This is also very interesting from the historical point of view. It took me probably 15 years to understand this information, to get the information. So now we are living in a fantastic new era. There are question marks and exclamation marks in the slide, you see, because actually it really depends on us. It really depends on what we are going to do, on how we are going to react to the challenges that...
I'm sorry, Madam, we can't
yes.
see your screen. Are you sharing your screen with us? Because we can't see your screen.
You cannot?
No, now it's black. It all went black.
Actually, it's... I'm clicking again the green button here.
Mm-hmm.
No one, okay, let me see. Now, because it says people can see your.
Now it's working. Yeah. Can you make it bigger?
Can you make it bigger?
Sorry, can you?
Can you make it bigger?
Can you make it bigger?
All right. It is actually 100%.
Okay, now we can.
Okay,
see
now we can see
everything is
the
okay.
screen.
All right.
Everything is okay.
Okay.
Go ahead with the.
So, all right. So, the opportunities we have today are really okay. Problem with audio. Can you hear me well?
Well, I can hear.
We have this problem with audio.
So I can hear pretty well.
So I'll
okay.
ask the attendees.
That's strange.
Okay?
So I'll ask the attendees. Just a second.
Anyway, so we have an enormous amount of challenges these days, and the fact that I put exclamation mark and question marks in the title of the slide is because it really depends on how we are going to react to the problems the world has today. There are enormous amount of problems, from energetic problems to political problems to overpopulation problems, and many of these social and health problems can be actually solved through computer science and IT in general. So the people that are gonna live today and study computer science today will have to face serious challenges. And actually, the fact that we can build a better world, it's really all in our hands. To understand the speed that is affecting our days, just think about some of the major inventions that have been deployed over history, like the Gutenberg press to print books, or the steam engine, the first industrial revolution, telegraph, and think that between one and the other, most often there are centuries. So between the Gutenberg press and the telegraph, you have 3 or 4 centuries, and just to make an example. But now things are much faster, and which is actually the Vatican Library, and think that the information of the Vatican Library, that it is enormous, huge, can be only found, can the same amount, not this precise information, but the same amount of information can be found these days easily online, just Googling a keyword. So in the past, the situation was much more complicated. For a scholar, for a researcher, you had to travel to the city, and so with all the problems related to the trip, to the travel, and you have to find the right book, the right piece of information in this huge library, and probably just the information retrieval was an operation that could take easily months. While what had to be done in several months in the past it means even 40 years ago or 30 years ago, now can be done actually in few minutes by pretty much everybody with some basic skill. And this is possible because some people, a number of people, invented the theory and the technology to be able to connect us to the world by just a simple cable. And in most of the cases, we don't even need a cable because we have Wi-Fi technology. And of course, all this invention, all these major changes in technology and in society brought important changes in our everyday life too. So up to probably 20 or 30 years ago, the kids used to play outside, play football or whatever sports. It really depends on the culture, on the square of the small cities, and that was the way of socializing. In the school, people used to pass information to each other, writing with pen and papers, and but now everything is different. Now there are many people that actually all the teenagers and the young people generally communicate pretty much only via mobile phone and Facebook. So this is a major change. Of course, there are many sociologists that are studying the problems that can arise from this major shift in the way that human beings socialize, because this is a new thing. This never happened in the last thousands of years, of course. And now I want to show you a 5-minute video that I don't know if Tanya wants to, or I can project it. Okay.
Manuel, now it's time for the video. Okay. Can you pause it?
Yeah.
So,
yes.
Dear listeners, I'm going to send you the link, and you should go to YouTube.
Yes.
And see the video. Okay, it's a 60-minute video.
Okay, it's a 60-minute video.
It will be better this way if you go to YouTube.
So now I'm sending you the.
All right. Yeah, you should go to YouTube and watch the video.
And then we'll comment it.
Yeah, later after you watch the video, right?
Yes.
Okay. Let me know if you
have any difficulty
opening this link.
opening this link.
You can use the question box. So I think we can watch the video, yeah, and then after
we will make comments.
Exactly. Thank you.
Professor, you may also play the video.
You may also play the video.
Yes. Okay, are you still there?
Yeah, I'm here, and I think everybody has watched the video. So now the
Yes. Okay.
on.
Yes. So many of the consideration that you watched in this video are UK based, but still this doesn't change much. I mean, because in every country you can find the same. The major point I want to comment and to introduce also consideration about computer science is software engineering is then in the video you can basically, and not only in this video, there are many articles discussing the fact that when you take a 3 years university degree, what actually you study could be outdated during these 3 years or maybe just afterwards. But there is an important difference I want to comment between the two verbs, to form and to inform. And this is the substantial difference that we are going to give you not just the information. So we are not going to make you aware of something. We are going to shape, instruct you, educate in a way that what actually you are learning at the university will be not outdated by just a change in technology, okay, or a new product coming out, or a new operating system, or a new paradigm for development. Descartes is in his discourse on method describe what we know today by the method of science. This is a very interesting book that you may be interested in reading, and you have to understand that computer science has its method too, and to have a significant change in the methods of computer science, it involves a major shift. So if you learn the basic, if you learn the fundamentals, if you learn the methods, it's very difficult that your knowledge will be outdated just in a few years, okay? And by the way, you are learning way of thinking, mental structures, a toolkit of methods, and conceptual tools, not only software tools. And with this toolkit of methods and way of thinking, you will be very good at solving problems. And when you have the skill of solving problems, this is not something that will be outdated very easily. So this is what we will try to give you in this course, and of course in every other course. So more than describing a technology, we will of course describe technologies, but we will give you the understanding of how this technology relate each other and how this technology are built, and now you can think about the foundation, the fundamentals of these technologies. So we are gonna always giving you different alternatives. So we will describe different technologies, different frameworks, different paradigms, because I notice very often that especially in the scientific community, people learning a specific method or a specific tool, they tend and they pretend and they want to apply this tool for everything, okay? So there is the famous Maslow law. Maslow is the scientist who described the pyramid of needs. And he wrote a very nice book about psychology of science. And he said that it is tempting, if the only tool you have is a hammer, to treat everything as if it were a nail. So if you know only one tool, you will be persuaded, you will be somehow forced, you will be tempted to use that tool. So I think a big mistake that we could do teaching this course, and of course every other course, is that we should really give you a toolkit, a different set of methodologies, so that you can try and understand to apply the best for each different case. So you will learn the basics and the fundamentals, you will learn technologies, and especially you will learn to learn. So very difficult that your knowledge will be outdated, unless, of course, there will be a major shift happens, a major scientific shift happening. But this is very unlikely. So you can trust that what you are learning here from many points of view is similar to what people were learning in the 70s or in the 80s, plus modern technologies. So you have a big advantage because you are studying the same fundamentals, but you are studying more modern technologies. And if you combine this, this knowledge, this information in the right way, you will be easily become a very good professional in IT or in computer science. Why do we need software engineering? We need software engineering for many reasons. One of the reasons that without precise technology we can incur in major problems. These are just some of the most famous issues in IT history. For example, in 1999, the Mars Climate Orbiter actually went into a wrong trajectory and disintegrated into the Mars upper atmosphere because there was one module providing information okay, I will tell you this later because this is just an overview. And another major problem is probably many of you know, this is 1993 when the floating point unit of the Pentium processor had a problem. Another one I want to mention is the faulty Soviet early warning system in 1993. Okay. For each of these, I will suggest you an article that you can read on the Wired, you know, probably this magazine, Wired, the website, and you see that this metric math mistake. So basically, there was a piece of software that was calculating the force in pounds, and there was a separate piece of software that was assuming that actually it was not pounds, but it was the metric unit, it was newtons. So, and this is. It's a really trivial mistake, but this is what happened. And this is also a nice article, The Man Who Saved the World Doing Nothing, and it describes how actually this officer, Stanislav Petrov, that was working with this monitoring system that was monitoring all the ballistic activity, and actually there was a mistake, and his human decision prevented a big catastrophe. So I will really advise you. I really advise you to go deeper and deeper into these topics, because only if you understand these faults and the potential damage coming out of this. Sometimes this damage has been fixed by the human intervention, but some other it couldn't, and some disaster happened. So we need software engineering. So we need basically systematic, discipline, and quantifiable approach to develop and maintain software. Because another problem is maintaining software, is maintenance. Okay, we are very good at building software, but then we have guaranteed that software is gonna work and it can be updated efficiently for years and years after his deployment. Okay, so this is what software engineering is. And inside software engineering, of course, there are many subtopics. One important topic that we will discuss is software reuse. If you look at general application, this is a general picture of general application, there are so many standard reusable parts like a graphical interface, the deployment, the data model, communication, and there is usually up to 30% of standard reusable parts and 70% of application-specific code. So why do we need to rewrite all the time that 30% if we can reuse? So software reuse is one of the major questions, one of the major issues of software engineering. And so what we do is basically there is a methodology called divide and conquer, which is inherited from politics, where divide and conquer in politics is basically about gaining and maintaining the power, breaking up concentration of power and splitting into pieces so that each of the opponents cannot be strong enough to attack you. No? This is a very well-known strategy in politics and also military strategy. It is well-known since the Roman time. We have the same divide and conquer in software engineering, where you have a big problem and you want to separate and you want to divide, you want to organize the big problem in smaller problems, and then still smaller and smaller, and you get components. Components is not a new concept because it comes from thermodynamics, it comes from chemistry, and but it is also applied to electronics, of course, and more recently you apply it to like these Lego pieces. You can apply the same concept of components to computer science and software engineering. So the definition of software component is a reusable, substitutable software artifact. So a packaging of executable software with published interface. The interfaces are necessary because other pieces of code need to know in a simple way what that actual component is doing and will do. And then you need, of course, a glue code to put the pieces together, a component framework. But we will discuss this in detail, of course, during the course. This is just a general overview. Software construction is about taking these small pieces and put it together in a way that you can get the final application. So the real application that is meeting the requirements of your customer or your requirements. So we have reuse of code, divide and conquer, and software construction. These are three major points that we will discuss in details during the course. Why the composition of software is so important? For many reasons. I'm gonna here present just two of these reasons. One is the fact that you can formally, mathematically reason on code. And in this way you can do very easily because you can calculate the properties of a system combining the properties of its subsystems. So if you have the system S, which is the composition of the component 1 and the component 2, the meaning, PS means the meaning of S, is a function, the meaning of a component is a function from inputs to outputs. This will be discussed during the course, and especially will be discussed in another fundamental course at Innopolis, which is the theory of computation. Okay, so basically you can project the meaning of the two components and obtain the meaning of the compositionally the meaning of the major system. Okay, so doing this way you have what is called functional modeling. So the system is modeled by composition of functions. Okay, so you can reason formally, mathematically on the components and on the system. So if you know how the components are behaving, you can state properties of the full system. And this is one, from the mathematical point of view, is an aspect of major importance. But there is another aspect of component-based development, which is productivity. In this diagram, you see over time, from the 70s to most recent years, how basically we went from unstructured programming, even before in the 50s, from structured programming with languages like C, object-oriented development, and component-based development with C++ and Java. And then there is a more recent thing, which is agent-based development, but this is something that we will not discuss during the course. Just a little bit, but not much. We will go through some technologies. As I told you, we want to teach you methodologies plus technologies. So we cannot discuss all the technologies in the course, but we will give you the instruments to learn more technologies by yourself. But we will go through this technology: remote procedural core, RMI, Corba, NET, software-oriented computing, cloud computing. And of course there will be exercise, a lab exercise, and we will go into the details of each of these technologies and frameworks. This is just an example. For two reasons I want to give you this example. First of all, to show you one of the technologies and one of the paradigms. Second, because this is an UML activity diagrams, and UML is a semi-formal specification methodologies for object orientation and component development. We will deeply describe and use during the course. So you will see many of these diagrams. You will see many programs described using these diagrams and many others. Okay, this is just one of the many diagrams used by the UML, Unified Modeling Language. Okay. And finally, in the last part of the course, we will describe cloud computing. Cloud computing is a very recent thing. Actually, the trend over the last 40-50 years was going from centralized systems, so mainframe, to distributed systems like today. But now we are moving to the next step. Cloud computing is a new way basically to centralize again the information. So you will have this, like this picture I took from the internet, these mega data centers. And basically all the services, all the software will be offered by a service which is not physically located anymore on your machine, but is somewhere else. So we went from centralization to distribution, and now we are going again back to centralization, but in a different way, because it's a mix of centralization and distribution. This is interesting. We will discuss this later. So don't be afraid to ask questions. I will try to answer all your questions today, or of course offline in the future. Thank you.